And so Engine Performance 1 Test 8 is talking about homemade lightning, ignition system diagnosis and service. Adam's are pulling some spark plugs out right now. I believe the problem we have on that cold running Mustang is fuel related, because there's not any other thing I can find. And I know there was some greasy stuff in that tank. And the plugs are looking greasy, like somebody has got some diesel fuel in it or something, so we're going to have to, it runs good when it's warm though. Let's see, number 1, ignition control is the term used to describe the PCM produced signal that controls ignition timing. This may be also called any of these except spout, dis, EST, IC. Spout, you remember, how many of you guys remember setting a timing on that Bronco out there? You got to pull the spark output connector. That's spout, right? This one here, basically, you're not going to call it DIS, that's distributorless ignition. That's not the PCM produced signal. Technician A says on bypass type ignition systems, the ignition system is timed by the ignition module when starting. Technician B says after the engine starts, the ignition system does not use the PCM to time spark plug firing. Who's right about that? B, what are you talking about? What is that? In a bypass, on bypass type ignition system, it's timed by the ignition module when starting. I do not like that question because it's sort of confusing. Technician B says after the engine starts, it does not use the PCM to time. That's not right because it always uses the PCM for spark plug firing. All right, I'm going to sign that one. I'm going to sign that one. And you put that one on my desk if you don't mind, sir. Okay. All right. And look, we have extensions. 2 of them. Can we please hold on to these and not let them get gone? I bet I could probably put 10 of these in there for some reason. I don't know what happens to them, but make sure we hang on to these extensions. And they're not breakable, see, so you can't claim you're broken. Here's, you take one of those that you need there. All right, so I'm going to say number 2, regardless of whatever anybody may think, is actually going to be, the technician B is right, and technician, I would say C, both of them is right. Because when you're spinning it over, your ignition system is, it's basically starting on that. I mean, that's one of them things. Waste spark ignition systems are being discussed. Technician A says it requires more voltage to fire the compression cylinder than the companion cylinder. Technician B says waste spark systems using the compression sensing electronics do not require a cam sensor for engine position. And that's C. Both those guys are right. It does require more voltage to fire the compression cylinder. Which statement below is correct? It's not possible to control ignition timing for each cylinder separately. Is that true? That's not true, is it? You can control each one separately. When you got a knock sensor and it picks up a ping on one cylinder, it can control the cylinder, the ignition timing of that one cylinder. Ignition control circuits cannot sense the voltage required to fire a spark plug. Is that true? That's true. All coil-on plug systems require ignition wires. Is that true? Is that true? What's true and what's not true? Are we tangled up here? The only one that is true is D. Coil-on plug systems use 1 ignition coil per cylinder. All the other things are wrong. They can sense the voltage required to fire a spark plug. All coil-on plug systems require ignition wires is not false. The following statements are all correct except, and that's on number 5. Knock sensors require voltage input from the PCM to function properly. That's not true. The knock sensor, kind of like an oxygen sensor, it creates its own voltage because it's got a piece of quartz in it. And when it's squeezed quartz, piezoelectric, it makes voltage on its own. So that's the way that's the correct answer. Number 5 is A. Coil-on plug ignition systems have which of the following advantage over waste spark systems? What do you think it would be? Will it reduce electromagnetic interference, decrease cost, fewer spark plugs, reduce number of ignition coils? What's the only thing that can be right? Think about it, y'all. Somebody give me an answer. If I've got 8 coils, am I going to be spending less money? Yes or no?
No.
No, I'm not. Okay. If I'm going to use fewer spark plugs?
No.
Reduced number of ignition coils? What's the only thing that can be true? Electromagnetic interference. I'll tell you something else though. Sometimes you may see a problem with a cop coil system. particularly on some of these Fords, that give problems that are crazy problems that seem unrelated to anything, and you'll have one bad coil-on-plug coil that's causing everything. I'm talking about dashboard screw-ups, crazy stuff going on, just all kinds of because of interference. Now, you got a bad one, sometimes they'll do that. All right, identify the type of ignition system shown in this diagram. Can you do that? Is it capacitor discharge, coil-on plug, distributor ignition, or waste spark ignition?
B.
Everybody like that answer? That's B. Coil-on plug. Identify the type of ignition system shown in this diagram.
Waste spark.
Listen to him. He knows the stuff. It's a waste spark ignition system, meaning it's firing when the piston's at the top of the exhaust stroke. It fires each, the spark plug fires every time the piston comes up. And the only one that does anything, is that. All right, which statement below is correct? A pickup coil should be diagnosed with a meter set to DC volts. Is that true? Don't you remember, you guys had a worksheet on checking the pickup coil on that engine out there on that stand, right? Remember that? And you're supposed to put your meter on AC volts to check it. B, a voltmeter is a better tool than a digital storage oscilloscope to diagnose an engine position sensor. What do you think about that? Number 9, let's look at this. Pickup coil can be diagnosed using a digital storage oscilloscope. That's true. That's the only correct statement in the whole bunch. Now, I've never even seen any, I may be wrong, but in the ASC test that I've taken, and I just re-upped on 4 or 5 of them this year, I've never seen a question that says which statement below is correct. Usually the only closest thing they have to this is everything statements true except. And Technician A says, they do have a lot of Technician A and B questions though. Technician A says a voltmeter can be used to monitor the output signal of an optical sensor. Technician B says optical sensor should be tested with an oscilloscope because of the sensor speed. Who's right? B is right about that. An optical sensor, you know what an optical sensor is? Basically, you gotta imagine yourself with a plate that's got a bunch of slits cut in it. And you got on one side of that plate, you've got a detector, and on the other side, you've got an emitter. And it's trying to shine through that all the time, and there's places in the plate where there's slots, and there's places where there's not. And so basically the receiving is gonna only send a signal when it gets a shot from that beam. It's kind of like this thing here that I showed you guys before that I designed to tell about, to read light on all that. See, I can actually shoot my red laser in there and it turns on that green light. It's the same kind of deal. Imagine this thing, if you got a wheel in between there that's spinning, and every time that it can't see that, you're getting a signal. That's what, I got an optical distributor over there somewhere you can look at. But that's what that's about. And a lot of them have that. And so number 10 is basically going to be B. Which condition could be caused by a distributor that has been installed incorrectly? Intermittent misfire, engine surging, light bucking. All of these are correct. If you've got your, like on the ones that have a crank sensor down there, you're not going to change the timing by turning the distributor. When you turn the distributor, all you're changing is rotor alignment, and if there's a cam sensor in the distributor, you're changing the phase of that cam sensor. If you put the thing in there so that it's a slightly out of time, then the spark coming off the rotor will hit the wrong post, and it'll make it buck and jump when you're driving down the road at a steady speed. And it took me a little while to learn that when I first started encountering those. Number 12, all of the following statements are correct except D. All of the statements are correct. Oil and dirt may cause high resistance in electrical connections. Electrically conductive rubber hose can be used when testing some ignition system with secondary circuits. I got a funny story. Incorrect routing of secondary ignition wires may cause electromagnetic interference with computer circuits. You ever notice how a piece of heater hose, a lot of them have got little fiberglass strands in them? Well, there was this guy that I was working with back in 1977 at a shop over in Enterprise. And he had there was a 75 Monte Carlo that he was working on that was quitting out there on the road. And he was gonna, and he told me, and this is sort of a bad idea, but he told me, he says, I was doing a tune-up on a Toronado or something. He says, follow me No, he says, if I'm not back in 30 minutes, come looking for me. I'm going out Geneva Highway. I said, okay. So I'm over here and I'm doing my work and I looked and said, oh my goodness, it's been 40 minutes and he's not back. So I took off and went after him. He was out there doing the slow burn because I'd forgot about him, you know. So I went out there and he goes, and it was still not starting. And so he says, okay, he forgot to bring anything with him, check spark. So he got a piece of heater hose that was in the back of the shop truck and he cut a piece of it and he stuck it over his pocket knife. You know, and he was going to hold that piece of hose and stick his tip of his pocket knife in there and check to see if he had spark. And little known to him, the spark had come back. And not only had it come back, but it ran up those fiberglass and fired him up good. You wouldn't think it'd go through a piece of heater hose. You know what I mean? A piece of heater hose he had was that long. But that fiberglass was, you know, just fired him up really good. I mean, and it started right up after that, you know. But my goodness, it was a mess. Anyway, he was not happy with me because I forgot him. And that was incidentally, that was a pushback wire at the bulkhead is what it was. It was causing it to just touch sometimes. Let's see. Technician A says it changes the position of a waste spark ignition coil to diagnose an ignition misfire. Technician B says a defective coil should cause problems on the cylinders it's connected to. Basically, both cylinders is what he's saying, and that's number 13. Well, that says that, but I mean, this says supposedly put C if you want to get that right in case she grades them. But I'm gonna tell you, you can have one cylinder misfiring and the other one, another one coil tower will go dark and the other one will still fire, even though they're both part of the same coil. I've seen that repeatedly. I got some coils in here I can show you that do that. So keep that in mind. Just because you pull the wire off of the one on the companion doesn't mean the other one will stop firing. You know, even though it's a loop, if you look at the way it's, you know, popping.
Dodge Neon did that.
Huh?
Dodge Neon, that
Yeah.
coil back in the top.
Yep.
Would do that.
Yeah.
Cylinder 4.
Yeah. But I mean, the neon is kind of a screwball because to get a good spark check on it, you got to check from one side of that same coil to the other. If you just try to go to ground, you won't get a very good spark on that one. All right, let me see. Number 14. Am I on the right one?
Yep.
All of the following statements are correct except in A, defective crankshaft sensors may cause the fuel system not to operate correctly. B, crankshaft sensors may be either magnetic pickup sensors or Hall effect sensors. C, crankshaft speed and position sensors only affect the ignition system. Or D, an ignition module should be replaced if it's not switching the ground circuit to the coil or supplying the coil with battery voltage. What do you think about that? That's C, actually. Crankshaft speed and position sensors only affect the ignition system. That's true on a crank sensor, but sort of not. And the reason I'm saying that is if you don't have a crank signal, you won't have spark or fuel injection because the fuel injection starts there too. And so, you know, keep that in mind as well. Also, here's something else you need to know about ignition systems is if you can go to the trigger side of the ignition coil when you're spinning it over and see the ignition, whatever's triggering it, if it's a PCM or if it's a module, pulsing that coil. If the coil's got power going to it and the ground is being pulsed, then you're going to have a spark if the coil is good. If you're not seeing a pulse, go back for whatever is supposed to be sending a pulse. If you are seeing a pulse, you got a bad coil. And if you're trying to check for spark, make sure you're checking it for it to jump at least, I'm going to say, I like for it to jump 7/8 of an inch and farther. If it won't jump at about 1/4 of an inch, you're probably not going to start that vehicle. But a lot of your textbooks will say, let it jump 1/4 of an inch. I want to stretch it while it's jumping and see it go, whap, 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 you know, where it looks like Frankenstein. Okay. Which of the following could cause poor engine operation on start? And that would be number 15, would be poor ignition wire condition, excessive wear and distributor cap, incorrect firing order, all that stuff. You know, I've seen that before. Technician A says platinum tipped spark plug should never be regapped after using in a running engine. Technician B says spark plugs should not be removed from a hot cylinder head. Technician is correct. Well, both of those guys are correct, but anybody, you know, most of the time, people pull spark plugs out of hot cylinder heads anyway. You know, some people say, well, if you pull it out of a hot cylinder head, you may bring the threads with it. I've never seen that. And I've pulled a lot of them out hot. But I mean, you know, use your judgment. If you decide you want to wait till it cools off, it's a little more comfortable to work on anyway. Number 17, which of the following would cause carbon foul spark plugs? Rich fuel mixture. It was going to look similar to the one, Adam, that you were showing me a while ago. Mm-hmm. You're going to have, that's not really carbon foul because that's going to be a dry soot. What you're looking at is sort of a greasy stuff. Which of the following could cause oil foul spark plugs? And what you're got out there is not exactly oil foul, but the effect is the same. You know what I mean? Number 18 would be D, defective valve stem seals. But listen to this. I want you to look over there on the wall. Look right there. See that ice cream looking junk right there on that spark plug? That puffy brown stuff? When you see that on a spark plug, you can categorically say that that engine has bad valve stem seals. Because whenever the valve stem seals, when you shut it off and they dribble a little bit in there and it makes a deposit on the spark plug and it bakes it and turns it hard, and every time that thing heats up, it adds a little more and a little more and a little more. That's what valve stem seal deposits look like. And you can, but that doesn't necessarily mean you need to rip the engine apart and put valve stem seals in it. I want to know how fast it's getting that way. If it's got, huh?
Take your tire off and replace
Yep.
it.
You seen some of them?
No, making a joke.
Oh.
Yeah.
Yeah. All right. I thought you had run across that. I would tell you, I've also seen spark plugs like that cause a surge. And when you unplug the EGR valve, the surge would go away and it'd fool you into thinking it was EGR. You know, but if it looks like brown ice cream, but it's a hard custody deposit, that's actually valve stem seal issues. And you're going to run into that on your 350 Chevrolets and stuff a lot. You know, they do that. I've seen them on other cars too, not just the 350 Chevy. All right, where are we at?
19.
We're on 19. Okay, let me see if I can find 19. I'm missing a page or something. I don't know what the deal is on that. Somebody read 19.
And this is water from a spray bottle can be used to define defective secondary ignition.
You can do that. You can take water from a spray bottle. Whenever you got spark plugs, you know, wires here, you can mist some water from a spray bottle. And I would use soapy water because it breaks the film. And if you see a lightning start popping out of the side of the spark plug, then you're going to do better on that. 20, technician A says some ignition systems should be put in base timing mode before setting ignition timing. And basically that's true. And don't worry about what technician B says because he's a yo-yo. So on 20 it's going to be A. Which statement about secondary ignition scope patterns is correct? And that's going to be close spark plug gaps cause longer than normal spark lines. Spark lines should be around 1.5 milliseconds long. Worn ignition components cause shorter than normal spark lines. This is what they're talking about. Some of you guys may seen me draw this before. This right here is a firing line. After it fires, it's going to burn a while, and then it's going to run out of gas. It's going to burn up all the gas, and you're going to get an upkick, and then you're going to get this. All right. The length of this from here to here is the spark line. The height of this is the firing line. You got me? This is the firing line. This is the spark line. Whatever goes this way won't go that way, and whatever goes that way won't go that way. You got me? So if you got a spark plug gap that's too close, this is going to be short and that's going to be long. You got me? It's like you've only got so much string to draw this picture with. And if you take some of it from up here, if you put more up here, you don't have as much here. You got that? That's all that is. That's all they're talking about right there. This is leftover energy after the gas. You're going to see an upkick if everything's like it ought to be. Now, Mac Vandenbrink is a scope guru, and he can look at a scope pattern and tell you if you got a rounded off lobe on your camshaft. He's sharp as a tack on that kind of stuff. As a matter of fact, I've got a doggone really nice PowerPoint that he sent me on that I actually bought it from him. Let's see. What the testing device is shown in this illustration. Now, I've got one of these out there somewhere, or I did have. That's a spark tester. It's different from the spark tester you guys were using this morning on that Sable out there.
We use something like that.
Huh?
Checking our, it's like 2 steps and stuff.
A coil is being checked with the following results. What does this mean? What are you thinking? Number 23? That's going to be C. The coil secondary is open. And that's an auto ranging meter. There you go, Daniel. And, all right, we got about just a few minutes to whip through this next one here. Won't be a problem. The ratio of on time relative to the period of the complete cycle is what? And we're talking about computers and networks on this test 9 here. This is slightly different than what we were talking about before. It's page chapters 18 and 19. That's your other test there. So number 1 is C. That's going to be duty cycle. That's the on time relative to the period of the complete cycle. Which data set contains only 2 digits? What about it?
Binary.
Binary, very good. 0 or 1. Which computer function is defined as a voltage signal from a sensor or switch?
Input.
Well, that's basically gonna be a, wait a minute now. Yeah, that's what I would like to say, input. I would say input, I wouldn't say output by any means. Which computer function describes how the computer handles inputs? Process, that's not hard. Which computer component generates a steady stream of 1 bit long voltage pulses? That's the clock generator, exactly. Which term describes the process of manually adjusting variables such as speed, load, and spark timing to determine the optimum output settings for the computer?
Performance program?
That's engine mapping. It kind of looks like a landscape with every little thing in it being a cell. And remember, I told you some of them, if it's not purging the canister in a particular cell, they call those purge-free cells and all that. Which component is affected when a PCM is flashed or reprogrammed?
EEPROM.
Yeah, the erasable EEPROM. It juices it up with 18 volts, wipes it out, and then it rewrites the stuff in there. It doesn't take very long. You'd be surprised what a small file that is. It's not very. Which one now?
They're both A.
Yeah. Okay, which sensor is used to determine engine load? What about the map? The map sensor. Which term describes the speed of data transmission?
Baud rate.
Baud rate's a good answer. Serial data that is transmitted by, serial data is data that is transmitted by a series of rapidly changing voltage signals. Moving on, a control area network, or CAN, vehicle network, allows communications at speed of, what do you think? B, actually 125,000 to 1,000,000 bits per second. That's actually gotten faster in recent years. It was only like half that fast. It was like 80-something thousand to 500,000, and now they've gone up with it. A digital multimeter set to read ohms is connected across terminal 6 and 14 of the DLC. The meter reads 60 ohms with the key off. What does that indicate?
C.
B?
A normal condition. Believe it or not, that's basically when you read 60 ohms, you know that the terminating resistors and all, whenever you got them all stacked together, they're going to come up to 60 ohms. If you read something other than that, you got issues. And you got to go find out which module, which wire's cut, which, all that kind of stuff. So that's those are the basically measuring that. It's a good plan. Low speed class A networks operate. I'd actually unhooked the battery before I made that measurement, though. By the way, low speed class A networks operate at less than how many bits per second?
C?
That's going to be 10,000. Yeah. Technician A says module communication networks are used to reduce the number of wires in a vehicle. Technician B says communication networks used to share data from sensors, which can be used by many different modules. Both those guys are right. So you can take the ABS module and you can get the speed signal, the vehicle speed signal from that. You can use it for cruise control, PCM, speed limiting. How many of you have ever been in a car that changes things that you wouldn't think that changes with speed? Like your intermittent wipers will change with speed. You may have them set where they're sweeping once every 5 seconds. And as you get it going faster, they may sweep every 3 seconds and then every 2. They change that interval based on engine speed. And a lot of times they're getting it from a sensor that you wouldn't think it would be coming from. I mean, getting it from a module.
I've been on one that's got the radio boost on it.
Yeah, it'll change the radio volume going down the road. You might have seen that before.
PC as well, doesn't it?
Yeah. Which was that now? Which one?
What?
We're on 15.
Oh, 15, yeah. 15 is going to be, 15 is going to be D.
No, I meant like,
Oh. It's going to be C.
Yeah.
14.
The computer will automatically clear a diagnostic trouble code if there's no additional faults after how many warm-up cycles? Hey, 40. 40 warm-up cycles. A pending code is set when a fault is detected on what? The first fault of a two-trip failure. See, some of them won't turn on the check engine light until the fault has occurred 2 times. And a lot of times if you go 2 more times and it doesn't reoccur, it'll clear the code for you automatically. So a pending code is set, wait a minute, I'm sorry. The generic scan tool can access the same freeze frame information as enhanced original equipment scan tool. That's false. Number 19, the mill is turned off if any of the above. Power to the PCM is disconnected. Vehicles driven on 3 consecutive trips with warm-up cycle and meets all. I said 2. This says 3. Whatever. Codes are cleared with the scan tool. any of those. Which term describes a set of conditions allowed to require each monitor to run? What do you think that would be? In other words, each monitor, like it's got to monitor the catalyst, it's got to monitor the evap system, it's got to monitor, that's going to be enabling criteria. Now, the continuous monitor stuff, like it's watching the voltage from the various sensors to see when they're going to fail, that's continuous monitor. The ones that have to meet, like for instance, you cannot just start the car and immediately have a PCM check, for example, the catalytic converter. Because it's got to get to a certain temperature and stay there for a certain amount of time before the catalytic converter can gather a data that's reliable. And so it's basically there are enabling criteria. That's what they're talking about. A customer states her mill is blinking. Technician A says this condition may damage the catalytic converter if the customer continues driving. What does a blinking mill mean? Some of you guys remember? A blinking malfunction indicator light means
Misfire?
misfire, big time, yeah. And if a misfire is happening and it keeps squirting gas in there, which just about no engine will nowadays, all the PCMs are set up so that if it detects a misfire on a particular cylinder, the injector is turned off after a certain number of misfires so that it's not squirting gas in there. However, if the injector is faulty and the computer can't turn it off and it keeps squirting gas in there, see where I'm going with that? All right. Now then, that number 21, by the way, is C. Both of them's right. If a customer continues driving, technician B says freeze frame data should be stored. Yeah, hang on to your freeze frame data. Call them up. I'll be ready in a minute. All right. Yeah, same thing. So, all right. OBD2 requires the PCM to detect faults allowing emissions that exceed how many times the FTP standard? Listen to him. He remembered that. 1.5. All of these are OBD2 requirements except A, tell the technician what's wrong with the engine. I'd say that's the exception right there. That's not going to tell you what's wrong. Which OBD2 term describes the check engine light? What's that now? D, mill, yeah. Malfunction indicator. Parameter information display is included in which OBD2 generic mode? That's D, mode 1. Mode 1. Technician A says disconnecting the battery is the best way around to erase, stored OBD2 diagnostic trouble codes. What's wrong with that? I mean, if I tell you what used to tick me off. Customer would say, come in and say, I had a check engine light came on. Well, where is it now? Well, I disconnected the battery before I came over here. Unless it turns into a pending code, you just wiped out everything that we had there for a second. And anti-lock brake stuff used to turn on the anti-lock brake light only while the problem was present in the early days, and sometimes it would flash the code, so you'd know right away. Let me see. Now on number 26, put B on there. Technician B says disconnecting the battery may not erase stored freeze frame information or DTCs. Actually, it will. I don't even like the way they did that. That is basically going to be 26. It should be a D. Put a D down there. I don't like it because you're not going to maintain your freeze frame data if you disconnect it. Technician A says a loose fuel cap could illuminate the mill. Technician B says loose fuel cap could cause a BO320 diagnostic trouble code. That's A only. BO320 is not the right one. He's thinking about a different one. That's not even in the ballpark on that. Technician, the vehicle has a stored DTC for oxygen sensor fault. This could cause what?
Monitor not to run. The catalyst monitor not to run.
Yes, absolutely. Yeah, that's a smart cookie there. A monitor that has not run to completion will indicate what on the scan tool? Incomplete. You can actually get a little thing. It looks kind of like that blue driver thing I got, and that will plug into your DLC, and you can just drive the vehicle without even worrying about it. And whenever all the monitors have cleared, it'll go beep, and it'll let you know. So you ain't got to have a scan tool in your lap. You can just drive around and let things beep. You know what's the hardest monitor to clear? The dadgum evaporative monitor. You'll drive that son of a gun all over Dothan or somewhere before you get the evaporative monitor clear. Remember, it won't clear if it's below 15% gas level or above 85. So you got to be in roughly the half tank range. Which first digit code indicates a network fault? What? U. You're right. That's correct. I didn't hear you the first time around. Everybody happy with that?